Today we're going to talk about the law of sines. So last year and in Math 2 we learned the right triangle trigonometry and its applications. In this section the solutions to oblique triangles, ones that do not contain a right triangle, are considered. So recall when we're doing right triangle trigonometry, because that's what we're going to have to use to help us solve these triangles, we have SOHCAHTOA. So sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Consider the triangle ABC with h as an altitude to side BC and k is the altitude to side AC. So notice that triangle ABC for both of these is not a right triangle, so we are creating an altitude for both of them. In this case, this one is h and this one is k. So we created that altitude so that we do have two triangles that are right triangles, because that's what an altitude does. So first of all, it says complete the sine of B equals h over c. So here we have angle B, so that makes sense because it's opposite in hypotenuse. So if we solve for h, we are going to multiply both sides by c and get c times the sine of B. So all we did was multiply both sides by c to get rid of that and solve for h. So if we were solving for c, so for c, we have c is equal to, the sine of c is equal to h over b, opposite of our hypotenuse. So if I want to solve for h, multiplies both sides by b to get rid of that. H is equal to b times the sine of c. So if we set these two expressions equal, because they're both equal to h, is why we're allowed to do that, we get c times the sine of b is equal to b times the sine of c. And if we divide both of these by c and b, notice this cancels out and the b cancels out, so we get the sine of b over b is equal to the sine of c over c. So we can also do that for this triangle over here. So if we were to solve for the sine of c is equal to opposite over hypotenuse now, which is a. So sine of c is equal to k over a. So if we solve for k, we get a times the sine of c. If we solve for the sine of a, which is k over c, if we solve for k, we get c times the sine of a. So if we set these two equal, a times the sine of c is equal to c times the sine of a, and divide both by ac, the side lengths. So if I cross that out and cross that out, we get the sine of c over c is equal to the sine of a over a. And that's where the law of sines comes in. So the law of sines is nice because notice then that as long as we have some specific measurements, we can do this without having to have a right triangle. We can just use sines. So in conclusion, in one triangle ABC, we have the law of sines. In any triangle, the ratio of the sine of an angle to the length of the side opposite is a constant, or the sine of a over a equals the sine of b over b, which equals the sine of c over c. Note that the reciprocal of these fractions are also equal, which we have right here. Generally, we use whichever form is more convenient. So for the law of sines, you can use the law of sines on triangles that are given angle, side, angle, 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 side, and side, side, angle, which this side, side, angle is actually the ambiguous case, which we are going to talk about later. So we'll come back to that later in the year. Standard notation. So standard notation, the vertex is labeled with a capital letter, and the length of the side opposite the vertex is denoted by the same letter in lowercase. So if we want to label the triangle ABC below, we can label it however we want. So if I pick this to be vertice A, so vertex A across from that would be side A lowercase. If this is B, then across from that would be lowercase b. If this is C, then across from that would be lowercase c. All right, so next says use the law of sines to solve the triangles. Draw the figure if none is given. So that's the first thing I'm going to do is draw a triangle. Okay, so let's go ahead. If call this A, we'll call this B and C. You can kind of pick, of course, your triangle may not be drawn to scale, but that's okay. So C is, it says 28 degrees, B is 42 degrees, and then we're also given the side opposite B, which is 10. So we don't know angle A or side A, and we don't know side C. So notice the given information that we have is, in this case, side, and then angle and angle. So this is a side angle angle, or you could write angle angle side, same thing. So that means we're allowed to use the law of sines. So if I set up my information using my law of sines, the sine of B over B is equal to the sine of A over A, which equals the sine of C over C. So for this, we have the sine of B, which is 42 degrees, over B length, which is 10, equals the sine of C, which is 28 degrees, over little c, which is also equal to the sine of A over A. So you can solve whichever ones you want first, doesn't really matter. So of course I couldn't solve the sine of 28 degrees over C equals the sine of A over A, so I'm going to take this off for right now, and we can solve this. Before I even solve that, I can solve for the angle A. So remember that all the angles in a triangle add up to 180 degrees. So angle A is equal to 180 degrees minus 28 degrees minus 42 degrees, which is equal to 110. So that means that this is 110 degrees. Please make sure you always label angle measures in degrees for your triangles. That is something I'll be looking for. So we get A equals 110. Okay, so if we solve this proportion here, again, notice I put the sines on top and the side lengths on the bottom. We can cross multiply. So here, if I cross multiply C times the sine of 42 degrees is equal to 10 times the sine of 28 degrees. And then if we solve for C, we have sine of 42 being multiplied. How do you solve for something being multiplied? You divide by that. So this is gone, and we're left with C is equal to 10 sine 28 degrees over the sine of 42. So that's when we're going to get our calculator out. So make sure you get your calculators out or on your computer. So if I go to my mode, first of all, I want to make sure I'm in degree mode. Otherwise, you're going to get all these problems wrong. Your calculator automatically, when you clear it, defaults to radian. So always make sure you check that, especially if you're doing any standardized testing. So we have our degree mode turned on first. Now I can go ahead and type in my equation that we have. So we have 10 times the sine of 28. Don't forget to close that parenthesis, and I'm going to close that one twice because this is all in the numerator, which is why I put it in its own set of parentheses, divided by the sine of 42 degrees, close parentheses, because otherwise you might get a different answer, and enter. So for this we get 7.02. So we're going to round the side lengths to 2 places. So in this case we have C is equal to 7.02. So round side lengths to the nearest hundredth. Okay, so again, side lengths nearest hundredth and angles nearest tenth. And so now we have C is equal to 7.02. And so the last thing that we need to solve for is, of course, side length A. So for that one, I'm going to use the sine of A, which is 110 degrees, over A is equal to, and I'm going to use the sine of B over B again because that was given to me in the problem. And notice that C is a rounded length, so we always want to try to get the most exact possible answer as we can. So it's better to use what was given to you as exact in the actual problem. So the sine of 42 over 10. So if I solve this, I can again cross multiply. So when I do that, I get the 10 times the sine of 110 degrees is equal to A times the sine of 42 degrees. Divide both sides by the sine of 42 degrees. That cancels out, so really now I'm left with solving for a right here. So now I just need to get my calculator out to solve. So if I get my calculator out, we have 10 times the sine of 110 divided by the sine of 42. So that gives me 14.04. So side length A is equal to 14.04. And now we have found all the information that we need. So why don't you guys go ahead and see if you can do the next triangle on your own. When you're done, you can go ahead and unpause the video and we'll take a look at it. So for this one, same thing. We want to first draw a picture of our triangle. So we have triangle PQR. So P, we use this as Q and R. So P is 18 degrees, Q is 29 degrees, and we have side opposite R, which is 20. So this is, in this case, angle side angle. And now we can go ahead and start to solve. So we can quickly solve for R because R is equal to 180 minus 18 minus 29, which gives us 133 degrees. And now we can go ahead and use the law of sines. So the sine of 133 degrees over 20 is equal to, so across from P would be little p, across from Q would be little q. So we'll just go ahead and solve for P first. So the sine of 18 degrees over P. So again, you can go ahead and cross multiply. So P times the sine of 133 degrees is equal to 20 times the sine of 18 degrees. Divide both sides by the sine of 133 degrees. So P is equal to 20 times the sine of 18 degrees divided by the sine of 133 degrees. And again, you don't want to get this whole equation and type this whole equation in your calculator. Don't round before you get there. So now when you plug this whole thing into your calculator, you should end up getting P is equal to 8.45. And now we can go ahead and solve for side length Q. So again, sine of 133 degrees over 20 is equal to the sine of 29 degrees over Q. So cross multiply. And divide both sides by the sine of 133 to get Q by itself. And so Q is equal to 20 times the sine of 29 degrees over the sine of 133 degrees. And then you can plug that into your calculator to get side length Q is equal to 13.26. And now we have all the information for our triangle, all the missing pieces. So the next thing we're going to talk about is the area of triangles. So recall that the area of a triangle is area equals 1/2 base times the height. So 3 triangles are presented below. Determine the areas for each triangle if possible. If it is not possible to find the area with the provided information, describe what is needed in order to find the area of the triangle. So looking at this first one, area is equal to 1/2 the base times the height. So in this case, the base is 5 and the height is 12. So that gives us the area is equal to 30, and we don't know what the units are, so I'm just going to call it units squared because we're finding area. Looking at this one, we have this DF length is equal to 20, and this length right here is 8. So area is equal to 1/2 the base times the height, which is 8. So that gives us area equals 80 square units. And for the last one, we need area is equal to 1/2. We don't know which one's the base because there's no altitude. Um, so I don't know, is it the 12 or is it the 15? So if you were to use 15 so as the base, then could you figure out the height? That's the next question. So in this case, there's not enough information. So now let's consider triangle ABC, which is set up similar to the triangle above. Write an equation that describes the area of this triangle given the measurements of two sides of the triangle and the included angle. So we're saying that we are given two sides and the included angle, so side, angle, side. So we're just going to pick for each one which one we're going to do. So the first one I'm going to pick is this side. The included angle is going to be A, and this side here. For the next one, let's do this side, that angle C, and side A. And for this one here, so we did angle A, angle C, let's do angle B. So we'll do that side right there. So this is saying if we were given this side length, this angle measurement, and this side length, could we figure out what the area is equal to? So this is given, we're saying A, C, and B. So area is equal to 1/2 the base times the height. So in this case, what is our base and what is our height? So the base for this one would be B, because notice this is where it's going down. So we're saying the base is B. And we don't know what the height is. So we have to solve. But do we have enough information to find the height? If we know C, A, and B, yes, we can use the law of sines. So if we know this angle, we know that the sine of angle A is equal to opposite, which is H, over hypotenuse, which in this case would be C. And C, notice, was one of our given lengths. So we would say that C times the sine of A equals H when we solve. So the formula would be area is equal to 1/2 the base, which in this case is B, times C sine of A, because that's my H. So area equals 1/2 BC times the sine of A. Now let's say that the given information, instead of being angle A, we're using angle C. So C, side A, and side B. So again, area equals 1/2 the base times the height. So in this case, the base we're using, because this is the height, is again B. We don't know the height. We have to solve for that. But we do know angle C, so we can solve for H because we do know these two lengths here. So the sine of C is opposite over hypotenuse. So that means that A times the sine of C is equal to H. So now we can solve for the area. Area is equal to 1/2 B A sine C. So area is equal to, I'm just going to write this in order, 1/2 AB sine C. Looking at the next case, now the height is going is across from side length C, so that means C is the base. Here B was the base because the height was going down here, and here again B was the base, but now we're saying the base is side C, so just notice that is different. So for this one we are given angle B, side A and C. So area equals 1/2 the base times the height. So in this case, the base we are using is now base C. Height we need to find. So if we know what B is equal to, the sine of B is equal to H over A. So A times the sine of B is equal to H, and now I can write the area. Area is equal to 1/2 the base, which is C, times A sine of B, and if we just write that in order, area is equal to 1/2 AC times the sine of B. So hopefully you're noticing a pattern. Notice that the area always includes the two side lengths being multiplied, so 1/2 the two side lengths being multiplied by the sine of the given angle. So I'm going to go ahead and write that out. So notice, or note, that the area is equal to 1/2 the given side length times the sine of angle between the given sides. So this only works for, again, triangles that are angle, side, angle. So if you don't have angle, side, angle, that means you need to solve the triangle to get angle, side, angle to find the area. So let's go ahead and practice. So it says find the area of the triangles, draw a triangle if none is given. So in this case, the first thing we want to look at is what information is given. So we have side, the included angle, and the side here. So this is side, angle, side. So we have the correct information to solve. So the area is going to always be equal to 1/2 the given side lengths, 7 times 11, times the sine of the angle between, so 55.2 degrees. So then I can go ahead and get my calculator, and in my calculator I'm going to go ahead and plug that in. So 1/2 times 7 times 11 times the sine of the angle between. And we get 31.61 for our area. We don't have any units labeled, so I'm just going to say units square or square units, same thing. Next one says two sides of a triangle plot are 100 feet and 80 feet. So if we draw a triangle plot, we have 100 feet and 80 feet. The angles between those two sides is 88 degrees. Find the area of the plot of land. So again, we have side, the included angle, and the side. So we can go ahead and use our formula. So the area is equal to 1/2 times 100 times 80 times the sine of 88 degrees. When you plug that into your calculator, you should get the area is equal to 3,997.56 square feet.